Back at the kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe. Haven't been here for a while. You were in Pakistan for a long time. I was just on the Cape. But it's a big day in the Muslim community. Eid Mubarak. It's Eid.
Thank you very much. It is, although I have to here give my editorial comment. In most of the U.S., the Eid was on Sunday.
And tell us why.
It has to do with how people decide when the new month is going to start. Whether you are going to use a calculation, are you going to see the new moon? So it's a lunar calendar. So some people think that you have to see the moon, and some people use the new moon on Mecca in Saudi Arabia. So there are all these different ways, and again, we have talked about it, and I personally think it should be standardized. You can do that calculation-wise; it's not an issue. But this is just one of those instances where the most places in the U.S., including the Islamic Society of North America, did that on a Sunday, which was possible. It's not that they wanted to do it on a Sunday. Of course, when there is a possibility, sometimes there is a little bit of a shimmying to that, if it falls on the weekend. But our local community decided it's on Monday, and so it's a weekday.
I think a 3-day weekend is great. I fully support this decision. If it's malleable, go for the 3-day weekend.
Yeah, except that it's not a weekend and everybody's working, including my son is at school right now. So that's the problem. No, but I mean, I think so that's and that's an interesting part of sort of like minority context, right? I mean, because you don't have a holiday for that. Meaning to say you don't have schools and colleges off, but you manage it within that context. And people are quite, schools and offices and other places are very accommodating, at least in Massachusetts or in the Northeast. Nevertheless, it poses some challenges. And so, but that's part of this experience.
We're not going to talk exclusively about Eid today, Mr. Universe. We're going to talk about not even a supernova. We're going to talk about Nova, the PBS television show. I loved that show.
I love it too. So, but we are not going to talk about that. We are going to talk about... So Nova just means a new star and a guest star. This is sort of for...
An 80s sitcom. Like Love Boat. They had all sorts of great guest stars on that show.
So people have been looking at the sky for since humans have been around, and probably before humans. I mean, other hominid species also looked at the sky, but they've been keeping records of what changes. And one of the things humans had noticed was that sometimes a star appears where there isn't one. And that's what was called a guest star, and then it goes away. And of course, we oftentimes talk about supernova because it is...
Like an exploding star.
Oh, I was going to say because it's super.
Oh,
otherwise,
yeah,
we would not talk about it.
It's what makes it more super than a nova.
That's exactly right.
Yeah.
So that's a big explosion that you get a star that becomes really bright because of its exploding, and in fact, it can be bright as the whole Milky Way galaxy. But then you also have stars that just become a little bit bright and then fade after a few weeks or so.
One-hit wonders, as it were.
And that's what a nova is. Supernova also fade away, but nova are just a fainter version of those. And there is an interesting thing that is we are anticipating this summer. We've already had our solar eclipse, which was...
highlight of 2024 already.
We've already had our aurora borealis.
Missed it.
Oh, you missed it.
Despite your best efforts to get me to see it through my phone.
That's right. And now there may be a possibility of seeing a star that we cannot see with the naked eye right now, but it may brighten up. Not the brightest star in the sky, but perhaps as bright as the North Star Polaris, which sometimes people think that it's the brightest star. It's not, but it's bright. You can see it with the naked eye. And so this particular star, it's called T Coronae Borealis. And this particular star is expected to brighten up anytime from today. And it could have happened in the last few months or so, up until potentially September.
That's crazy because Beetlejuice, which is not only a great movie, but I'm slightly skeptical about the sequel, but is a fun star name to say. We know that one is going to go supernova sometime, but it's like sometime between now and like a million years from now or something like that, right?
Right. And so I find this story really fascinating because this again goes back to the thing that normally we talk about in astronomy, timescales that are on millions of years or billions of years. And even when we talk about Betelgeuse, we go like, oh, it could have like, any time, which is possible. Like, you can actually see it sort of like, go this year. But we don't know. The error bars are so high. But this particular star, this is part of a binary system. So this is where what we understand about this star comes in. So here is a white dwarf. So white dwarf is the end state of our sun. When our sun is going to die in about 5-6 billion years. So we talk about again billions of years. The stage that it's going to be left of, the core, would be the size of the Earth and with the density of an atom. So stars like our sun die like that. Our sun is not going to become a neutron star. Our sun is not going to become a black hole. Its end state is going to be this white dwarf. And so here is a system where a star like our sun, a little bit bigger than it, became a white dwarf. But it was part of a binary star. There was another star as well, which is also like its sun-like star. And it has swelled up. So before our sun is going to become a white dwarf, it's going to become a red giant.
And consume all the way through Earth, at least.
Potentially Earth as well, and maybe Mars. And so it's going to become a red giant, a whole other thing, why it's going to happen and so on. But that's a temporary stage. So in this particular star system, this is T Coronae Borealis, you have this red giant orbiting this white dwarf, or they're both orbiting each other. These are binary stars. So one star has already become a white dwarf, and the other star is on its way to become a white dwarf at some point. However, right now what's going on is white dwarf, which is much smaller, but it has a lot of density, a lot of gravity in there as well. It is grabbing the gases from the red giant because red giant has swelled up, and its gases are being stolen by this white dwarf. And as the gases come around the white dwarf, they form an accretion disk, which we have talked about around black holes and other things also, in here as well. So you get this material from the other star that this white dwarf is stealing. That gases come in and swirl around this white dwarf and deposit on it. Now, that is all okay. And most of this gas is hydrogen because most of the stars are mostly made up of hydrogen and helium. Well, after a while, if you have a lot of material that is being compressed on this high density environment of the surface of the white dwarf, it gets heated up. And at some point, when you have enough material on top, it gets so heated up that you have a thermonuclear reaction, or you can also call it a hydrogen bomb or hydrogen fusion.
Wow.
And you have this explosion. Okay, so that is what is happening in this star system. But why do we know that it's going to happen in a few months? Well, because astronomers over the last couple of hundred years have looked at the historical records and have found this to happen almost around every 80 years. The last one happened in 1946, but there are records that happened before that in 1866 and maybe before 1787, and there is also a record in 1217. So people have been looking at historically. This is called a recurrent nova because periodic. So you can think about the science behind it. The gases come in on the accretion disk, enough material comes in, then you have this basically sort of like, a fusion reaction come in, some hydrogen bombs explode, it clears up material, and then the process starts to happen again.
So they've been watching this binary star system over the course of 80-year cycles since maybe the 1700s, and it's time to happen again. It's a little bit eerie because of how much, say, fascism comes in 80-year cycles as well. I'm not going to look at it as a dark omen. So I was like, what happened 80 years ago? Oh, I remember. It was World War II.
Well, but the interesting part is, I mean, I would go the reverse. 1946, yes, it was directly observed, but people have gone back into historical records. People didn't know that it would go nova. And this is special because only there are 5 recurrent novae in the Milky Way galaxy that we know of. There are 400 novae that we know of, but only 5 that are recurrent. So that's the other reason why it's important. But this particular star system is about 3,000 light years away.
So let's pause right there, because what we're going to observe sometime between now and September actually happened 3,000 years ago, because that's how long it took that light to reach us.
That's right, and the two stars are very close together. They are like closer than like half the distance to the Earth, to the Sun. So it's very close system. That's the reason why it could steal the gases from the other star. But there is another reason why this is of deep interest. One of the reasons is that we just talked about supernova. Well, eventually we expect this white dwarf to in fact end up as a supernova. If enough material keeps on piling onto it, there is this really famous work that was done by Indian American astronomer Chandrasekhar. It's called Chandrasekhar limit, and that is that a white dwarf cannot be above a little bit over the mass of our sun. You just cannot have it, right? So what happens? Well, what is expected is that over multiple times when this material keeps on going in and it is adding up to the mass of this white dwarf, eventually it will hit this Chandrasekhar limit. And when it hits, it's not going to be just a thermonuclear or nuclear fusion in there, but in fact the entire white dwarf is going to explode. That is one of the biggest explosions in the universe. This is called a particular type of a supernova. For people who know, it's called type 1a supernova, and that's going to be huge. And why we are interested in it? Because all type 1a supernovae with this particular type all have the same type of brightness. And meaning to say that every time a white dwarf like this in a binary system explodes, it explodes with the same brightness, which means, because astronomers are always looking for ways to measure distances, we know if you see this type 1a supernova far away and it looks fainter, that means we know the distance. This is called a standard candle, and these type of supernovae have been crucial in finding out about dark energy of the universe, because we can figure out the expansion of the universe by looking at these explosions.
I love that they're called standard candles. That's such a beautiful way to describe it.
Yeah, because that's what it is, and it's not the only way. So we also call it a distance ladder, because distances are the most important thing in astronomy, because you don't know if something looks bright because it's close by, or because it looks bright even though it's really, really far away and it just intrinsically is really bright. So how do we know that? How do we find that out? For that, you need to know distances. So anything that can tell us about distances, and the easiest one, of course, is the parallax, where you just look at your eye and that's how our brain interprets it. But parallaxes you can only measure for nearby stars. Type 1a supernova can give you distances to billions of light years, or at least about 1 billion light years or so. And that's why it's important. And if we can study what exactly leads to a supernova of a white dwarf, if we can study the details of it, then we would understand maybe if there are slight differences between the supernovae or not, because that's what astronomers argue about. Are they really exactly the same, or are they slightly different, and what leads to that? So this particular star, which is T Coronae Borealis, that's going right now nova. Eventually, it probably is going to go supernova as well. Not right now. We don't expect it to go supernova right now. But if you want to see this star, so right now it's actually in the northern sky. It's above. Look for the constellation of Coronae Borealis, northern crown. It's a sort of like a cup. It's a semicircle type of thing. And right outside of that semicircle is this star. Right now, you cannot see it with the naked eye, but just every day, go out and look at it. It's there are so many apps that you can find sort of like stars above. Look for Coronae Borealis. Familiarize yourself with it. One day, between now and September, probably, you're going to see a star that was not there. And it will last for about a week. So this is kind of cool that you can actually see something that happened. All of that said, I should give you one caveat. There is a lot of excitement. I'm an astronomer. I concur with the excitement. But I still think that our data is a little bit limited. I mean, it happened about 1946. The reason why we have narrowed it down so much is because a little over a year before 1946, this particular star system went through a dimming. We don't know why. It was called a pre-eruption dip. It just went down in brightness, and 1.1 year after that, you had the nova. And this pre-eruption dip, I sound like,
It sounds like something delicious you'd have during like the finals of the Celtics game.
That's exactly right. That pre-eruption dip happened last year in 2023, in March and April of last year. So that's the reason. So if you want to know why astronomers are saying that, it's because a similar dip, and people can look at the light curve, meaning to say how that star has been brightening or dimming. That happened in 2023 in March and April. So they expect that if it follows the same thing that happened in 1946, we expect something to happen by September. But you know what? Universe doesn't have to follow us, what we like. So that's what I think is going to happen. That's what astronomers think what's going to happen. If it happens, it's going to be really cool. And if it doesn't, well, then the dip is going to be even more mysterious. And why it didn't go nova, that will be another question, which we'll be talking about, I guess, after September.
If we find out it goes nova, we'll be sure to let you know.
Yes.
We'll let you nova.
And and also we will give you more specific directions where to look at it. And yeah, but look at the sky anyway. Forget about nova. Look at the sky. It's just spectacular. It's very hot these days, so you cannot make a complaint that it's too cold. Just get out there, look at the night sky, look up Coronae Borealis, look at this constellation, familiarize yourself. And if you see a dot next to it, a star appear, that is this T Coronae Borealis, a star that has gone nova. You are seeing an explosion on a star 3,000 light years away.